All right, in this example, we're going to go through looking at international trade. And in order to do this, we're going to be bringing together a few different ideas that you should already know. Let's just talk about them real quickly. First of all, production possibilities curves, making a graph, looking at all the possible combinations that a country could produce. The idea of opportunity cost, which is the slope of one of these production possibilities curves. And opportunity cost is how much of one thing you have to give up in order to produce one more unit of another one. And the other idea that's going to be built in here is the idea that voluntary exchange, voluntary trade, will make both parties better off. So let's see how that works. In this simple example, let's assume that we're looking at two countries, the United States and France. And the two products we're going to simplify the world down to in this model are producing wine or producing beer. So to try to keep this as simple as we can, let's suppose that both the United States and France have 100 people who work in the beverage industry. The big difference here is, even though they have the same number of workers that are producing these beverages, we're going to assume that their abilities to produce are slightly different. Let's suppose in the United States, each worker can make either 4 barrels of beer or 2 barrels of wine in one day. In France, let's suppose one of these workers we could either assign to be making 2 barrels of beer or 2 barrels of wine per day. And we're also going to assume here that these beverage industry workers use similar kinds of resources. Now remember, when we're looking at production possibilities curves, if we have two industries that we're looking at that have unique skills and unique sorts of inputs that go into making them, specialized resources, then usually we'll end up with a production possibilities curve that bows out away from the origin. If we're looking at something where the inputs used are perfect substitutes, they're just as good at doing one thing as they are doing something else, then we're going to end up with production possibilities curves that are straight lines. So what we're assuming here is our production possibilities curves are going to be straight lines. So let's build up this example, answering some questions along the way, and we're going to be graphing everything as we go to help us answer these questions. So first thing I want to do, let's draw the production possibilities curve for France. Now you should download this handout and print it out so that you have it in front of you. And I have two versions of the graph. I have a smaller one at the bottom of this page, and then on the second page I have a little bit larger version of the graph. So let me use the little bit larger version here. So for France, we assumed that they have 100 workers, and the production possibilities curve, what if all 100 workers in France were sent to produce wine today? Well, if each worker can produce 2 barrels of wine, then that's going to put us here at producing 200 barrels of wine. If we sent all 100 workers into producing beer, the other extreme, then we would end up in France with 200 barrels of beer. Let me zoom in to make that a little easier to see. And if we just connect those two dots with a straight line, we'll end up with the production possibilities curve. Okay, so the production possibilities curve for France is orange. Now let's do the same thing for the United States. In the United States, we assumed that each worker, same as in France, they could produce 2 barrels of wine per day each. So in the United States, let's do those in purple, we could end up at the same place. If we allocated all of our resources toward making wine, 200 barrels of wine, no beer. But on the other extreme, since in the United States, we assumed that the workers are a little more productive at making beer, each worker could make 4 barrels of beer in one day, then the other extreme allocation of resources would be down here at 400 barrels of beer. Similarly, if we just connect those with a straight line, then this purple line is our production possibilities curve for the United States. Now looking at these two production possibilities curves, can you see which country is going to be the richer, wealthier, better off country, the one that can produce more than the other? Of course, that's going to be the United States in this example. Since the purple line represents higher combinations of goods at every point except one over here, then the United States is going to be the wealthier country in all cases except where they choose this one extreme point to make nothing but wine. So let's go back to the handout and answer some of those questions. And the first question on the handout is, what is the slope of this line for France? Take a second and make sure you can see that. Of course, the slope of this orange line is -1, because if we go from end point to end point, we're going down 200 and over 200, so the slope is -1, right? So let's just write that over here. And what's the slope of this production possibilities curve for the United States? -1/2, right? If we just pick any 2 points, why not the end points? Down 200, over 400, -1/2. The next question asks, what is the equation of the production possibilities curve for France and for the United States? Often these can come in handy whenever you're doing these kinds of trade problems. So let's start with France. This orange line, what if we wanted to write an equation to describe this line? Well, y equals mx plus b, but we have on the y-axis wine, so we might write this, instead of y, w for the y-axis equals mx, okay, -1 is the slope, x is beer on the x-axis here, plus the y-intercept, well, 200, right? For whatever reason, economists, we normally like to write the y-intercept first, so I would personally write that w equals 200 minus b, or -1b. What about the equation for the United States? Similarly, we could write it as w, the amount of wine that we're able to produce, is equal to the y-intercept, which is also 200, minus the slope, 1/2, times how much beer we produce, so -1/2 b. Let's go on to problem number 2. In question number 2, it says, okay, in the United States, what is the opportunity cost to produce 1 barrel of beer? So if we want to produce 1 more barrel of beer, how much wine do we have to give up producing? Let's go back to the graph. So in the United States, we're looking at this purple line. So for every 1 unit, and in fact, we're going over 10 here, right? But for every 10 we go over, we're going down 5, right? So for every 10 beer we want, we're going down 5. So that's at the rate of over 2, down 1. In other words, for each additional barrel of beer we want to produce, in the United States we have to give up 1/2 of a barrel of wine, or half as much wine as the beer we're producing. And turns out that's just the slope. When you look at a production possibilities curve on a graph, the slope of the line tells you the opportunity cost of producing 1 more unit of the good on the x-axis. Because you're going over 1, you're going down how much? That's what a slope tells you, so down 1/2. So that gives us the answer to the first question. The opportunity cost of producing 1 more barrel of beer is we give up 1/2 of a barrel of wine. Now, what if we were to move the other direction? What if we wanted to produce 1 more barrel of wine? How much beer would we have to give up? Now, in general, when you go in the other direction, the opportunity cost of the other good is going to be the inverse of the opportunity cost of the first good. Since in order to get 1 more barrel of beer, we have to give up 1/2 of a barrel of wine, then what if we wanted 1/2 of a barrel of wine? We're moving in exactly the opposite direction. We'd have to give up that 1 barrel of beer that we just got, right? So in order to get a whole barrel of wine, we're going to have to give up 2 barrels of beer. Again, just in case that's not clear, let's go back to the graph here. And again, the easiest way I know to visualize this is to start down at this bottom end. Suppose we were at this extreme point in the United States where we had nothing but beer. And somebody said, hey, we need a barrel of wine. All right, let's super zoom in there. We need 1 barrel of wine. How many barrels of beer do we have to give up to get it? 1, 2, right? So for every 1 barrel of wine we want, we have to give up 2 barrels of beer. Now the units on this graph are in tens, but the same principle holds. So what this tells us is, if we're in the United States and we want more beer, we don't have to lose much wine production in order to produce more beer. However, that comes with a trade-off in the other direction, a bigger trade-off in the other direction, that if we want to get more wine, we're going to have to give up a lot of that beer that we would have been able to produce. In other words, we're relatively better at producing beer than wine in the United States. Now, what about France? Well, France is kind of an easy case because the slope is just -1. You can see that as we move along this production possibilities curve, we're always going over 1, down 1, over 1, down 1, over 1, down 1. So that tells us that if they want 1 more barrel of beer, they have to give up 1 barrel of wine. And going the other direction, it's the same. It's 1 for 1 all of the time for France. So that's an easy question. So the opportunity cost of 1 barrel of beer is 1 wine in France, and 1 beer is the opportunity cost of producing 1 barrel of wine if you're in France. All right, a couple of definitions here that are really the crucial things whenever you're talking about international trade and comparative advantage here. So, first definition, absolute advantage. Absolute advantage means that you're just better, cheaper, faster at doing something than someone else. Absolute advantage is something you're always comparing two people or two countries in, well, which person's faster, better, easier at producing something. You can produce it cheaper, faster, with fewer resources. So absolute advantage in producing something if you can do it with fewer resources, or you can be more productive. It takes you less time, less money, or less workers in order to produce something. Comparative advantage is if you compare two countries and one country can produce a good with a lower opportunity cost than the other country. So let's compare these two countries with the numbers we have, and let's see what we learn. Who has an absolute advantage in producing beer? In other words, if we look at these two countries, France and the United States, who can produce beer more easily with fewer resources? In order to see this, let's just go back to our original description up here. In the United States, one worker can make 4 barrels of beer. In France, one worker could make 2 barrels of beer. So which one is better at making beer? Workers in France or workers in the United States? All right, workers in the United States are better at making beer, and so we'd say that the United States has an absolute advantage in making beer. What about in making wine? Well, we saw that in the United States, one worker could make 2 barrels of wine per day. In France, one worker could make 2 barrels of wine per day. Which country is better, faster, can do it with less resources? Neither. So no one has an absolute advantage in making wine. They're equal. They're equally productive at making wine. And so again, the why is how much can one worker produce in each country is the way that we're thinking about calculating absolute advantage here. So since workers in the United States are more productive than French workers at making beer, the U.S. has an absolute advantage in beer production. No one has an absolute advantage in wine because they're equally productive. Question number 5, though, who has a comparative advantage? So remember our definition is you have a comparative advantage if you can do it with a smaller opportunity cost. You give up less than the other person does when you produce this good. So let's look at beer. Who has the lower opportunity cost of producing 1 more barrel of beer? Well, the U.S., our opportunity cost is 1/2 of a barrel of wine. In France, our opportunity cost is 1 barrel of wine. So whose opportunity cost is less? Right, the United States. So here the United States has a comparative advantage in making beer, who has a comparative advantage in making wine? If the United States produces a barrel of wine, we have to give up 2 barrels of beer to do it. However, in France, they would only have to give up 1 barrel of wine to do it. So, France has a comparative advantage in making wine. Now, in these examples we're looking at here, where there are only 2 countries and 2 goods, if the United States has a comparative advantage in, say, beer, then France will have a comparative advantage in the other good. If there are only 2 goods, and if somebody has a comparative advantage in one thing, the other country will have a comparative advantage in the other. That's just the way the mathematics works. So why is this true? Because France's opportunity cost in producing wine is lower than the US, but the United States' opportunity cost of producing beer is lower than France's. So the big lesson here is when you have 2 countries, the countries have different comparative advantages. These countries should specialize in producing what they're relatively better at or comparatively better at, and then trade. And the lesson is these countries can both be better off in this way if they specialize in trade. And this example is to demonstrate how might that work out. Question number 6, just to make what we're doing here simple, but also kind of disgusting, I say, suppose that everyone in the world has the same preferences, very simple preferences to make this easy. Let's suppose that everyone prefers to mix equal parts of beer and wine when they drink it. So 8 ounces of beer, 8 ounces of wine, stir it up and drink it. Now, I don't think anybody actually does that, but this is just going to help us focus on what kind of optimal production levels each country would want to do. What kind of consumption mix do we want to end up with in the end? And the answer is going to be equal amounts beer and wine. So let's start off by assuming we're not going to trade. Suppose these 2 countries have decided we don't like each other, we don't have a trade deal going. What would we end up doing if we weren't allowed to trade or just didn't want to trade for some reason? So how much beer and wine will each country produce, and what is the world total of each going to be? So this is the before trade outcome. Let's go back to our graph and see what would happen. Now we could do this algebraically or we could do this graphically. I'm a big fan of Graphical Solutions, so that's what I'm going to favor here whenever possible. So what I like to do here is draw what we call a 45-degree line, or x equals y line. I'm just going to draw a little line where the amount of beer and the amount of wine are equal. So we just want to draw through all these points where beer and wine amounts are equal, and that will kind of help us visually see what these countries are going to want to do and what they're capable of doing. All right, so this pink line represents the preferences. Everybody wants an equal amount of beer and wine. And so if we look at France, they're by themselves. They're not trading with us at all. Here are all their production possibilities on the orange line. Their preferences, where they want to be, is half and half beer, half wine. And so our point right here, where they're making 100 beer and 100 wine, is going to be their optimal point. What about the United States? Well, similarly, we're just looking at where the amount of beer they're making equals the amount of wine, except we're on our production possibilities curve, the purple one here for the United States, and they're going to end up at a point right around in here. Now, graphically, that looks like it's, let's see, 110, 20, 30. It's a little beyond 130 beer and 130 wine. Algebraically, this is going to end up being 133.33333 beer and wine. Now, how do we know that? Well, let's just take 1 minute aside here to come up with the algebraic solution. Remember that equation of the United States' production possibilities curve or line here, we had the amount of wine equals 200 minus 1/2 the amount of beer. If we want the amount of wine in the solution to be equal to the amount of beer, then we can just make the substitution. The amount of wine equals the amount of beer. So we could either substitute B equals W or W equals B and solve this for B. And when we solve that for B, we're going to end up getting the amount of beer equals the amount of wine is 133.33333 in the United States. So without trade, let's go write down our conclusions. So in France, they're going to end up producing 100 beer and 100 wine. In the United States, they're going to end up producing 133.333 and 133.333 barrels of wine. Let's look at the world total, right? What's the world total amount of beer going to be? Well, it's going to be 100 barrels of beer for the French and 133 barrels of beer for the United States citizens. Total of 233 1/3 barrels of beer. Same thing for wine. Now, why am I doing this? Well, I'm doing this so that we can keep track of something like world happiness, world utility. The assumption here is if by trading we can somehow increase the total amount of beer and wine produced and consumed, then we're assuming that's going to be a good thing. Everybody's drinking responsibly, though, right? Now, let's look at specialization. So as we said before, countries should specialize in what they have a comparative advantage in and then trade. Let's look back at the numbers. Since we said that the United States has a comparative advantage in making beer, why? Because every time the United States worker is assigned to make 1 barrel of beer, we, the world, are only giving up the ability to produce 1/2 of a barrel of wine. Whereas if we made people in France make that same barrel of beer, let's just assume it's the same barrel of beer, if they made the same barrel of beer, then it would cost a whole barrel of wine, right? So if I had 2 workers in front of me and I had to choose, who should I send to make the barrel of beer? The person who we'd give up making 1/2 a barrel of wine if they make the beer? Or the person, if they made the beer, we'd have to give up a whole barrel of wine? Of course, send the United States worker to make the beer. We lose less wine production when we do. And on the flip side, if we send the French worker to make 1 barrel of wine, we only give up a barrel of beer in production, but for every barrel of wine somebody from the United States makes, we're giving up 2 barrels of beer, right? What we want to do here is come up with some kind of solution where we encourage the United States to make most or all of the beer, or we encourage France to make most, if not all, of the wine. But there's this other constraint where people really want to have the same amount of beer and wine. That's to keep things simple, believe it or not. So let's see what would happen if we specialized, and then we can work out all the details of how these countries might trade. So number 7 and 8, these 2 questions here kind of go together. And so let's look at them together as we try to analyze this. So suppose we specialize what could happen. And we want to see if these 2 countries traded, one sent a ship over with beer, how much wine could they rightly expect in return? Now, when we figure out this price that they would be willing to trade, we have another constraint. And all these little constraints make this a little more complicated to figure out the right answer, although there are going to be several right answers we could come up with here. But one of the constraints we have here is, look, neither country is going to be willing to pay more for beer or wine than they could produce it themselves. In other words, in France, simple case, France always has the opportunity within their own country to trade 1 barrel of beer for 1 barrel of wine. So if they were to buy beer from the United States, France is not going to want to buy beer and pay 2 barrels of wine for each barrel of beer, because that's kind of harsher. That's a higher price than they could just do themselves. So whatever price France is paying to get beer from the United States, assuming beer is going to be mostly made in the United States, or maybe all completely made in the United States, that price can't be higher than trading 1 barrel of wine to get 1 barrel of beer. In order to really give France an incentive to do this, we want to give them some kind of a deal here where they can get a little bit more than 1 barrel of beer per barrel of wine they have to send over to us, right? So that's one way to think about the constraint. Now, what about the United States? What kind of prices would they be willing to pay at most? Well, if they're buying wine from France, they'd be willing to trade, let's see, well, internally, they can give up 2 barrels of beer to get 1 barrel of wine. So they're certainly not going to be willing to trade more than 2 barrels of beer for each barrel of wine. And if we're going to give the United States an incentive to trade, then we probably want to give them a little bit better deal than that, right? Maybe only have to trade 1.5 barrels of beer for each barrel of wine they receive in return. That would give the United States an incentive to trade here. Now, let's go to the graph. What I'm going to do here is try to figure out one possible fair trade price. There are going to be a whole range. The constraints are just what we said. The United States is not going to be willing to pay more than 2 barrels of beer per barrel of wine, whereas in France, they're not going to be willing to pay more than 1 barrel of wine per barrel of beer. Any range in between those two is going to work. Let's go to the graph and let me show you a little trick to help figure out one possible price. And basically, by looking at these two lines here, remember the slope of these lines represent the opportunity costs. How much the countries have to give up in order to get 1 more barrel of beer produced. It turns out that any price that represents a slope in between -1 for France and -0.5 for the United States, and again, this is going to be the price per barrel of beer, that any price between 1 barrel of wine for 1 barrel of beer and 1/2 barrel of wine for 1 barrel of beer, any slope, any price in between those two is going to work. Now, one thing we could do to figure out one of these average prices, just if we just wanted to make sure, is we could kind of average those two. And this is a kind of average. Let's see what happens, just visually. Let's see what happens if we were to add these two production possibilities curves together. So what if the United States and France both decided to only produce wine? Then all together they could produce a total of 400 barrels of wine, right? And then what if they decided at the other extreme to only produce beer? Well, France could chip in 200, the United States could chip in 400, and produce a total of 600 barrels of beer. And if we connect those two together with a straight line, what is the slope of that line? Well, we see that the slope of the green line, kind of the total, we'll get into that in a second though, is going to be sort of an average, some number in between the orange and the purple lines. And that exchange rate turns out to be one of the possible exchange prices for beer and wine between the two countries that would work. There are others, but just to get a feel for it, what is the slope of this green line? Well, down 400 and over 600, the slope of that line is -2/3. That exchange rate, that trading rate, would work. For every 2 barrels of wine that the French send over to the United States, then the United States has to send 3 barrels of beer. Just think about this exactly as a slope. Rise over run. Rise is wine, run is beer. So this tells us the exchange rate of wine for beer. So we could simplify this to just be a number like 0.67, right? Or round it off, 0.67. And that would say for each barrel of beer, I'm willing to send you 0.67 barrels of wine per barrel of beer. Or you give me 2 barrels of wine, I'll give you 3 barrels of beer. Everybody's going to be happy. Now here's a question to think about though. This green line, is this going to be the production possibilities curve of both countries? Here's the scenario. Suppose that France and the United States enter into a union, kind of like the European Union. But instead of the European Union, we're going to be the United States of Francia. And if these two countries decided, hey, we're just going to become one big country, would the green line be what their production possibilities curve looks like? The answer is no. I want you to take a minute and think about why the answer is going to be no. These two endpoints are correct, but what's happening in the middle is not correct. And this is where the gains from trade actually happen. Let's think about it this way. Suppose we were down here at this extreme point and all both countries were making was beer. We would end up with 600 barrels of beer, correct? But suppose we decided we didn't want nothing but beer, we want a little bit of wine. Which country are we going to tell to make the wine? Is it going to be the United States, where as we make wine, we give up 2 barrels of beer? Or is it going to be the French, where as they make wine, we only give up 1 barrel of beer for each unit of wine? Correct. The answer is going to be the French should be the first people we tell to make wine. So let me copy this line, the French production possibilities curve, and put it over here. Do that a little more precisely. So what this orange line is saying is, if these two countries were to combine forces and work together, and the very first workers that we send to make wine are going to be the French workers, then we're going to be going up 1 barrel of wine and over 1 barrel of beer, giving up 1 barrel of beer for each additional barrel of wine we want, right? So we see that slope of 1, that opportunity cost of 1. Whereas the United States' opportunity cost is going to be giving up 2 barrels of beer for each barrel of wine. Using the graphical approach, we can kind of see this is going to be part of that total production possibilities curve when both countries join forces. Now, can you see what we're going to do to figure out what the rest of that joint total production possibilities curve for both countries is going to look like? And if you said what we should do is take this line that has a slope of 1/2, and we should paste it up here, then you would be exactly right. And so it's the combination of the United States' production possibility frontier, assuming that as they produce beer, we want them to be the first people to produce beer. And then only if we want to produce more than 400 barrels of beer, should we then engage the French workers to produce beer. And similarly, if we started over here and we wanted only beer, but then we decided to start producing some wine, first the French workers should produce the wine, and then only if we want to produce more than 200 barrels of wine should we start bringing in the workers from the United States. What we are starting to see here is when we have two different kinds of resources, French workers and workers from the United States of America, who have different skills and different abilities, we start to see that bowed out shape away from the origin typical of most production possibilities curves. Now, what's our goal going to be if we enter into a negotiation between the two countries for trade? Goal number one, figure out an appropriate price at which it's fair to both countries. And by fair, I just mean both countries have to be willing to trade at that rate. And it might be better to call it incentive compatible. So we find a price at which it's fair or incentive compatible to exchange beer for wine. Okay, we already did that. Exchange 2 barrels of wine for 3 barrels of beer. Second question, how much beer and how much wine should we produce? And it looks like the optimal point is going to be right about here. On this pink line, where the amount of beer being produced is equal to the amount of wine being produced. And it looks like it's going to be about 270 barrels of beer and 270 barrels of wine. And we'll verify that that's a close answer in a minute. It's probably not exactly right, but let's say it's approximately correct just from looking at the graph. We'll come up with the exact solution in just a minute. So how could this happen if we're going to be in the entire world for both countries making about 270 units of beer and 270 units of wine? Well, what that's going to entail is all the French workers are going to be making wine, 200 barrels of wine, and then we're going to start allowing some of the workers in the United States to make wine. So they're going to be making the additional about 70 barrels of wine. And then the rest of the workers in the United States are going to be put on making beer. And again, they should be making about 270 barrels of beer. And so this result that we just got by looking at the 45-degree line and seeing that when both countries cooperate, specialize, and trade, that instead of world production being 233 barrels of beer and wine, that now by trading, they'll be able to produce more, about 270 of each, right? So this is the big lesson that we want you to understand about why economists are so strongly in favor of international trade, is that everyone can produce more if we do it in the right way. And if everyone can produce more, everyone can be better off. Now again, this is not exactly the solution, 270, but from the graph we can see that it's pretty darn close to that. Now let's figure out exactly what that point is. Again, we said approximately 270 of each. Let's do the math. What is the equation of this purple line up here going to be? Well, it starts off at 400. That equation is going to be the amount of wine equals 400 minus, what's the slope of the United States' production possibilities frontier again? Minus a half. Okay, 400 minus a half times the amount of beer. And again, what do we want the end result to be? Well, we want the amount of beer equal the amount of wine, so we can substitute just beer. So what are we going to end up with here? Let's see. Well, if we add a half B to both sides, we're going to end up with 3 halves B equals 400. And so the amount of beer is going to be how much? 266.66666. So 266 and 2/3 barrel of beer and 266 and 2/3 of a barrel of wine is going to be this optimum point. So pretty close to the 270 that it looks like on the graph, but not precisely. So let's figure out who should make what exactly. Exactly how are we going to be getting here? Well, we know that since the United States is going to be making all of this beer, let's see, how many workers would it take the United States to produce 266.66666 barrels of beer? Well, each worker can produce 4, right? So the number of workers in the United States that need to be making beer. So let's see, U.S. beer producers All right, so 66 and 2/3 of a worker. I know, let's not worry about the fact that we're not going to be chopping workers in parts, but what we could do is tell this worker, okay, from the morning when you get here until about 2 o'clock in the afternoon, we want you to make beer, and then after 2 o'clock, go and help out the wine crew. So it's easy to actually split workers like that during the day. And so that means that in the United States, we're going to have 33 and a third workers producing wine. And so in the United States, these workers are actually going to be making, that times 2 barrels of wine. So it's going to be 66.66666 barrels of wine. So this is what the United States is going to have to trade with when we start the trading round. They're going to have 266 and 2/3 barrels of beer and 66 and 2/3 barrels of wine to trade. Now, what are the French going to have as we enter at the docks and we start trading things? What are they going to start off with? Right, in this idea, they're going to be right here. They're going to be sending all of their workers to the wine factory, specializing fully in making wine. Okay, let's go write down everything that we know so far. When they specialize in trade, again, assuming that both countries are going to want an equal amount of beer and wine in the end, the world total production is going to be 266 and 2/3 of a barrel of beer, 266.6 and 2/3 of a barrel of wine. And the way that's going to go down is the United States is going to be producing all the beer and 66.6 barrels of wine, and France will fully specialize into wine. And if we go with that fair trading price that we talked about earlier, where the idea would be that the United States would send 3 barrels of beer for every 2 barrels of wine that they receive. In other words, at the rate of 1 barrel of beer they give up, they get 2/3 of a barrel of wine. But again, the big point is that the trading scheme itself is going to be able to take us to where we are better off than we were before. In the end, both countries will be better off than they would be if they tried to just be isolationist and try to do everything for themselves. Instead of 233 world production of beer and wine, we're up to almost 267 of each. If you're interested, let's delve in and find out exactly how each country is going to end up after they trade at this rate. Now, in order to do this, we need to carefully think about how we can set up equations that are going to represent what we want to happen in the end, and an equation to represent this trading scheme. Here's how I'm going to think about doing this. Let's think about this from the United States' perspective, and then once we figure out what the United States would do, France's actions and results will become pretty clear as well. So the United States is going to have to decide how much beer should it trade. So here's a little equation we can think about to represent that. That the amount of beer the United States is going to end up with is going to be 266.6, what they started with, minus some unknown number. This is what we're trying to figure out. How much are they going to actually trade to France? Now, how much wine does the United States have? Well, they're starting off with 66 and 2/3 barrels of wine, but then for each of these barrels of beer that they trade, how much wine will they get in return? 2/3 of a barrel of wine. And add the third thing, what's going to determine how much the United States wants to trade it to begin with? Well, their goal is to end up with the same amount of beer as wine. So we have another condition here. Beer equals wine. And so, like we've seen before, just making this simple substitution, we'll be able to figure out what's going on. Now, here's how I'm going to operationalize this substitution. Since I know the amount of beer is equal to the amount of wine, right, that third equation, I'm just going to set these two equal to each other and solve for x and see what pops out. So we know 266 and 2/3 minus x That's the beer. We want it to be equal to the wine. 66.6 plus 2/3 x. Collect terms. Not that hard. Subtract 66 and 2/3 from both sides. We get 200 on the left side. Add x to both sides. We're going to end up with 1 and 2/3 x's. Divide both sides by 1 and 2/3. And we're going to get that the amount of beer that the United States wants to trade is 120 barrels of beer. So if the United States trades 120 barrels of beer, how much wine will they get in return? They're going to get 2/3 of that. And 2/3 of 120 is 80. So here is our conclusion as to how this is all going to work out. So the United States is going to start off with 266 and 2/3 barrels of beer. They're going to trade 120 barrels. That leaves the U.S. in the end with 146 and 2/3 barrels of beer in the end. They're going to trade 120 barrels of beer and get 80 barrels of wine in return. Add that to the original 66 and 2/3 barrels of wine they already had, and this is when you know we've done something correct. They end up with the same amount of wine as beer. That's what we designed this to do. Now what about France? Well, France is going to end up getting 120 barrels of beer in trade. They're going to be sending 80 of their barrels of wine to the United States. And so France is going to end up with 120 barrels of beer and 120 barrels of wine. So each country ends up better off than they would have been without trading. Without trading, France would only have 100 barrels of beer and wine to consume. And without trading, the United States, we figured out, would have been at 133 1/3. With trade, both countries are better off because they specialized, increasing the total amount produced in the world. And by finding a fair or incentive-compatible trade price at which they can trade, we can see that they're both going to be better off after trade. Now, the last question you might want to think about here is, why is it that the United States ended up getting more than France? There are two parts to the answer here. The first part of the answer, in our example, the United States was the more productive country. Since the United States was the more productive country, meaning that their production possibilities curve is further out away from the origin, except at that one point up there, they're going to have more resources to trade with, and therefore they'll probably end up with more in the end. But then the other part of this is, what is that rate of exchange that we used? There are a lot of different rates of exchange that we could use here where they might be trading. And of course, how much beer the United States has to give France for each barrel of wine is of course going to affect the end outcome as well. This has been a long, complicated, but complete example so that you can see what the definition of absolute advantage and comparative advantage are, what countries might do if they were isolationist, and why economists are so strongly in favor of trade. With trade, world production of everything can increase as long as countries specialize in what they have a comparative advantage in, and as long as we find a way for countries to trade at a price that is beneficial to both countries. So this video covered an awful lot. If you have any questions, please let me know. But I think if you can really understand all the parts of this example that we went through, then you won't have any problems understanding the idea of comparative advantage, specialization, and trade, and how it benefits countries to specialize in trade. So this is Dr. Berkey signing out. As always, I wish you the best of luck with all your economic studies, and I'll talk to you later. Bye-bye now.